In the previous video, we learned about class decorators, which let us transform a class object in whatever way we choose. In this video, we'll look at metaclasses, which let us affect the creation of class objects right from the beginning. Like class decorators, metaclasses are a tool we can use to adjust the basic meaning of a class. In concept, though, they're very different. A class decorator takes an already created class and transforms it in some way. A metaclass, on the other hand, can affect how a class is created, how it behaves, and even how classes that inherit from the modified class are created and behave. To understand metaclasses, we first have to grasp the idea that classes are objects, and more than that, they are instances of another class called type. Anytime we create a new class, we're creating an instance of type, unless the class has a metaclass. If the class we're creating has a metaclass specified, or it inherits a metaclass from its ancestors, then the new class is an instance of the metaclass, rather than being a direct instance of type. That sounds like we could change the behavior of a class completely by giving it an unusual metaclass, but actually, all metaclasses have to resemble type, or Python wouldn't be able to use them properly. Most of the time, metaclasses are actually subclasses of type, which makes things simple. Alright, so what can we do with a metaclass? First of all, we can run code before the code inside the class block is evaluated. For each class, which is an instance of the metaclass, we do this by giving the metaclass a prepare method, which should be a class method or a static method because it will be called before the instance is created. The prepare method is passed the name of the new class and its list of parent classes, as well as any keyword arguments supplied by the user. The prepare method can do whatever we want it to, but it should also return a dictionary or similar object that could be used to hold the class's attributes. We can pre-assign values into the attribute dictionary from inside of prepare. So we can actually assign attributes to the class before it even exists. That brings us to the second thing that metaclasses can easily control, the class's namespace. In our last example, we returned a dict instance from prepare. So instances of this metaclass use a normal dictionary to store their attributes while their code is being evaluated. But we can return any dictionary-like object from prepare. For example, we could return an ordered dict if we wanted to keep track of the order in which attributes were created, or a default dict if we wanted all attributes to have a default value. We could even use a weak value dictionary if for some reason we wanted the class to not protect its attributes from being garbage collected while it was being evaluated. Of course, those are just dictionary-like classes that exist in the standard library. We could also return a custom dictionary-like class from prepare, which could conceivably do almost anything. If we want a class that ignores the case of attribute names while its code is being evaluated, we can do that. There's a reason why I keep saying while the code is being evaluated. After prepare is called, the code inside the class block is run, and it uses the dictionary that was returned from prepare as its namespace. But after that, the metaclass's new method is called. One of the things new needs to do is to call type.new to actually allocate and initialize a chunk of memory to contain the class data. And one of the things type.new does is convert whatever we pass it as a namespace for the object into a normal dict. This means that if we want to retain special information that our namespace object knows, we need to store it somewhere where we can find it later. We can make whatever changes we want to the internals of the class once we've created the class object in the new method of the metaclass. We can programmatically add, remove, replace, or wrap the class contents, much as we could in a class decorator. We can also return something that isn't actually a class object at all, just as we could with a class decorator. The difference, aside from a bit of extra typing, is that subclasses of a class that has a metaclass will also inherit that metaclass, while class decorators are not inherited. That means that using a metaclass we can make our unusual behaviors inheritable. This example makes it so that any class that descends from the class where the metaclass was originally applied can find all the other classes that also descend from that ancestor. In this video, we saw how to use a metaclass to affect the construction of a class object and how to make unusual behavior inheritable by making it part of a class's metaclass. In the next video, we'll move to a less esoteric topic and discuss context managers.